I'm going to take you on a quick tour of Google Earth right now to show some of the solid tectonic processes. I'm going to have a number of these small tours posted for the coming topic modules. They're there for two reasons. One, to help you visualize some of the things you're going to be reading about in the book, and also so that you can think a little bit about the degree to which your area might be impacted by some of these areas as you have to talk about each of them. So the first place we're going to go is probably the least exciting of all. This is going to be an area that just has what are sometimes referred to as basic platform deposits. Platform deposits are areas that have large flat sedimentary rocks laid down on top of older materials, craton-like materials that are talked about in the text. And a good example of this is the prairie areas that are found in parts of the United States and Canada, where you have these big flat areas, essentially, lots of sedimentary rocks on top of these older rocks. As you start to move your way up into the north, you actually get onto what are called shields. And we can sort of see that shield showing up north of this part of Manitoba. And those shields are the very old craton-like rocks. Now we can go from here to slightly more exciting things. And one of my favorite solid processes are areas where you have lots of folding. And we're going to go to central Pennsylvania, and this whole area through parts of the Appalachians stretching down into Virginia and Tennessee is a tightly folded area. And you're going to see those folds very closely as we zoom down into central Pennsylvania. These folded mountains are all sandstone. They're separated in between by limestone valleys. And we're just going to fly down and look at one of those valleys. This is called Kishicoquillos, or Big Valley. On each side of these valleys are fairly steep sandstone ridges caused by the folding. From here, let's go to an area that is a basin. A basin is an area that has been pushed downwards. Michigan is a good example of an area that tectonically is forced downwards. Now, it's filled up with sediment. These are mostly glacial sediments. But if you look around the edges of Michigan in the Great Lakes, you actually see that there are a series of escarpments. These escarpments are actually created because this whole area is pushed down, so these areas sort of pop up along the side. And the Door Peninsula that forms Green Bay is a classic example of this escarpment. We're not going to be able to see it all that well, but this is a ridge line that sort of faces towards the west. We can see a similar thing if we fly all the way to the other side and look at an escarpment called the Niagara Escarpment. And of course, it's famous because Niagara Falls goes over that escarpment, which we can see through here. There are a number of different domes. A dome is where an area is pushed upwards, and probably the two most famous domes are the Black Hills, which are located in South Dakota. And here we can see this whole area has been sort of pushed up, and these ridges that surround it sort of face inwards. Another dome is known as the Nashville Basin. It's not really a basin. It's a basin insofar as there's this big, broad area in the middle that a lot of streams flow into, but you can sort of see around it these ridges, and these ridges face inwards. They're caused because that area in the basin itself is actually pushed upwards. Now, the next thing to look at is faulting. Faulting is where you actually have fractures in the crustal material. The most basic fault is found in a classic escarpment like we see in the Grand Tetons. Lots of faulted areas throughout the West. They're often identified by these sort of blocky-like mountains that you can find in different places. Let's fly down and take a look at the Tetons in particular. Here you can see this block of mountains that's been thrust upwards with very sharp breaks on each side. Those are faults, normal faults, and the steep side of each face is called an escarpment. And you can see quite clearly what the Teton escarpment looks like right here. Now, another type of fault is called a thrust fault, and that's where actually rock is thrust up over the top of other material. And for thrust faults, we're actually going to go to Alaska. And once we're in Alaska, we're going to go to the western Chugach. So these are the mountains that we are most familiar with. You might have noticed before, especially if you're a hiker or a climber, that really the highest peaks of the Chugach are all located in this area that sort of emerges around Eagle River and pushes back into the glaciated areas of the western Chugach. This is called the Eagle River Thrust Fault, and it's an area where rock is thrust up and over the top of another kind of rock that's found in the Chugach, which is the Valdez group. And probably the best place to see this thrust fault is from a glacial perspective called Whiteout Pass. And as you look from Whiteout Pass down the Eklutna Glacier, you can see these really dramatic peaks emerging all around the Eklutna Glacier. These are all mountains that have been thrusted upwards. And now we're going to fly out of the glaciated area down to Eklutna Lake and see the dramatic bold peak and its neighbors that are also all created through this thrusting mechanism. Now we're going to go from here to California, where we're going to see a transform fault, not quite as exciting as the thrusted one, but a very active area. Most of you are familiar with this San Andreas Fault that runs all the way from San Francisco down to Southern California, where you have rocks moving laterally next to one another. If we go to San Luis Obispo, we can actually see where that fault line is. You can see the fault right down through there, the San Andreas Fault, and look how there are mountains pushed up around it. These areas have been structurally deformed by the fact that you've got these this tension being created in the San Andreas Fault. Now the last place we're going to go and look at is going to be to the east of this area, in the broad area called the Basin and Range. This is Nevada and Utah. And if you take a look at all these mountains right here, you'll see that these mountains are all block faulted mountains with normal faults on them. But when they're all put together, these areas are sometimes referred to as bolsons. The text shows some pictures of this, but a bolson includes a block faulted mountain surrounded each side by a broad valley that's been pushed downwards, and the sediments that fill that area, with the mountains over to the side here. Another name for this is also a horst and a graben. The horst are the areas that are pushed upwards. The graben are the areas that are pushed downwards. And that concludes the Solid Tectonic Features tour.